Sorry I'm not in class today, but hopefully this video will replace me at least for a little bit, can help you out, learn the law of cosines. Any questions you have on the law of sines, I will answer those when I get back. So we'll just start. Looking at the objective law of cosines, pretty obvious. And basically when you look at our language objective, we're going to summarize the law of sine by filling in a chart, and you'll see that as it goes, which is interesting here when we are doing the video portion is you can stop, and actually I'd like you to at various points pause, stop the video, work the problem, do it yourself, and then come back and then watch how I do it. Again, the learning part, if you just watch how I do it, you can probably see it, it makes sense, I get it, but when you do it on your own, you're going to be making mistakes, it's going to get frustrating. If you do the work on the side and then watch how I solve it, if you're wrong, you'll see where the mistakes are. You'll learn from that. If you get it right, that should build your confidence as you go through this. But hopefully you'll have a good time exploring some of this and seeing how it works. The other part of the language objective, we're going to find the easiest way to solve a triangle when you use the law of cosines by discovering rules of thumb or little golden nuggets. So we're going to come up with that and figure that out. So let's go on with the lesson here. Basically what I'd like you to do is just right now on a piece of paper, just write down what you need to know to use the law of sine. So this is a good time to pause, write some quick stuff down, and then you can play and continue. Alright, now that you're back, hopefully you've written some of the stuff down, but let's take a look at this. Some of the things that we need to know for law of sines. We need to know angle, side angle. We would need to know side angle, and this one right here is what we spent a lot on class time doing all those various cases. Case 1, case 2, case 3, case 4, whether you have 1 triangle, 0 triangles, or 2 triangles off of it. And then we also have side angle, and if you notice, I put down here, you use the law of sines. To use the law of sines, you need to know an angle and the side opposite. So here I have an angle and a side opposite. Here for angle, side, I have an angle and a side opposite. Here, you don't necessarily have an angle and a side opposite, but hey, we can use the triangle sum theorem where 3 angles of a triangle add up to 180. So I will know this one, and now I'll have this angle and the side opposite. So whenever you have these 3 types of triangles, you can use law of sines, being aware of the ambiguous cases for this one. So what I'd like you to do is I want you to fill this chart in for the ambiguous cases for side angle or the other way around. But here, obviously, you're going to put the possible numbers of triangles, draw a quick sketch of kind of what it looks like, the conditions necessary, however you want to write that, and then if these conditions necessary are kind of confusing, remember you can do the math. What is it if you're just doing the math, not looking at the conditions, but just doing the math? What do you have to do to just do the math to do this? So this is a great time. Hit pause. Yes, hit pause. Write this stuff down, fill in the chart, and then come back and you can continue with the video. All right, so popped up the answers here. If you want to hit pause just to take a look, copy some things down, but this is kind of a general idea. Maybe there's a better way to do it as I look at yours. We'll see how that goes. When you're done again, click play and you can continue and we'll go from there. All right, I would like you just to solve this triangle. So hit pause, solve the triangle, and when you're ready, come back. I guess this is the welcome back time, or maybe you just blew right through it. Anyhow, when you look at this, if I tried, most people just did law of sines because you don't know law of cosines yet, but if you try, you'll notice, hey, if I do law of sines, I have too many variables here. I don't know enough to figure anything out. And this is the issue with law of sines. We don't have enough information to help us. So what other congruency axioms do we know? We talked a little bit about this last class, but I'm formally putting it up here again so you can see it. Is these other 2, side angle side and side side. These are the 2 types of triangles where you're going to have to use law of cosines. Law of sines won't work just to start out. So that's what the rest of this lesson is about. So we'll keep going and take a look at this. Let's go back to the original, oops, kind of not original problem. Little FYI here, I gotta throw this one in. List the angles from biggest to smallest. So again, pause. Tell me which angles are biggest to smallest. Angle A, angle B, or angle C. Hopefully you had a chance to do this, or you've already remembered this from geometry, but I'll do a quick review. A is going to be the largest because the largest angle will always be opposite the largest side. B will be the smallest because the smallest angle is always opposite the smallest side. And of course, C will be the middle angle because it's the middle side. So basically, again, to sum up, the largest side is always opposite the largest angle and the smallest side always opposite the smallest angle. Something to keep in mind as we work through these problems. It'll help you out. All right, so back to our original one. Here we can't find B using the law of sines, so we're going to need a new law, and that is the law of cosines. So here is a formula for the law of cosines. It's pretty straightforward. B squared equals A squared plus C squared minus 2AC times, this will be a big one, times cosine of angle B. And if we use this, I can just walk through the steps. I can write this out. There's my B squared, which I'm looking for. My A squared, 250, plus the B, or plus my C squared equals 2 times A times C times the cosine of that 135 degrees. If I go through and punch this through the calculator, I'll kind of walk you through this again. If you need to slow it down or pause, go for it. I square the 250, square the 400, get the various sides here. 2 times 250 times 400 times the cosine of 135. And if I continue, I'll add these together. It gives me 22,500. And the 200,000 times this cosine of 135 is this 141,421.36. Add them together, take the square root of both sides. We're basically winding up that side B is 603.25. So we're able to do that. And then from here you can use the law of sines to find one of the other angles, and then the triangle sum theorem to find the other angle, etc. from there. So you may want to play around with that, check your answers with your neighbors. Otherwise, continue on with the video. So ultimately, these are the laws of cosines, these three formulas. Now, like I've mentioned in class before, you can memorize the formulas or you can just understand the concept. With law of sines, instead of memorizing sine of A over side A equals sine of B over side B, I usually would phrase it as the sine of an angle divided by the side opposite. And then it doesn't matter whether I'm looking at A, B's, or C's. Take a look at these formulas. There's some patterns, there's some similarities. You can start thinking of sides and angles and how those relate without actually remembering the letters. But if remembering the letters is good for you, then that's fine. You can remember the letters. But let's use this again and see how this works. I want you to find side A using the law of cosine. You can pause here and work through it, or just watch me as we go. So basically I'm going to look at this and say, okay, I'm going to use this law of sines that matches. I'm looking for side A, but again, if you understand the concept, it really doesn't matter what formula you're using there. And I just start plugging things in. A squared, the side we're looking for, is equal to 15.4, or B squared, plus 12.9 squared, which is my C side, minus 2BC, which is 15.4 times 12.9, times the cosine of 42.3 degrees. And then at this point, it's just plug and chug into the calculator, get it figured out. I can square the 15.4, square the 12.9, and multiply all this out at once, gives me 293.1. Combine like terms, square root both sides. So now that I know, side A is 10.5 inches, feet, whatever the units are. What I would like you to do is find angle B. How could we find angle B? Well, I know an angle and I know a side opposite. Pretty straightforward to find law or use law of sines to find it. So let's go for that. Sine B over 15.4 That's the angle I'm looking for over the side opposite equals the angle I know over the side opposite I know. Cross multiply, divide out by 10.5, and if I plug and chug, I'll get 0.9871, take the inverse sine of that, and voila, you get 80.1 degrees and 99.2 degrees. Stuff you've already done, but remember, we're getting two angles. Now the question is, which angle? So I'm going to walk you through this. You don't have to write this down, it's already in the video, but take a look, understand what's going on. If you want to write it down, great, because it'll be good for you to look back on. So here we go. I'm going to say this is 80.8 degrees. I have a choice of the two. Remember, there's only one case where you're going to get two triangles, and that's in the law of sines in the ambiguous case. The interesting part here is when I use this, I'm using side-side angle, so I could kind of have an ambiguous case, but we know this is only going to be one triangle because we used law of sines originally. So I'm going to use the 80.8, and what I'm going to do is add these two angles together. I want to check. Adds up to 123.1, and that means if I subtract from 180, angle C should be 56.9 or somewhere close to there based on your rounding. Okay, does that make a triangle? Sure, those add up to 180 or pretty close. One thing you can look, if you remember the FYI slide we had a little bit back, here's my biggest side. What's opposite the biggest side? It better be the biggest angle. Here's my smallest side. What's opposite the smallest side? It better be the smallest angle, and then of course the middle. And since this is the case, this could work. Probably does work. This might be the answer, but how do you know? So let's continue. You can do this again. Let's check our 99.2 degrees. Well, I can add the angles, add the 99.2 plus my original 42.3. I'll get 141.5, and if I subtract from 180, because of the angles have to add up to 180, angle C should be 38.5. All right, well, let's take a look. I mean, this works mathematically, but does it work logically with our understanding of geometry? Let's look again. The biggest side does have the biggest angle of 99.2. The smallest side, 10.5, is this angle smaller than the C value we just found? And it is not. So in this case, this does not work. It can't work because it doesn't fit the triangle inequality theorem that was learned in geometry. So be careful when you use the law of cosines first to solve. You do have two angles. Which one could it be? One can work, one will work, and one won't, and it's just trying to figure out which one works, and it takes a little time to go through that. All right, so for starters, we found 10.5. Let's go kind of back to the beginning. I found 10.5 as the side of this triangle. And the last couple slides, etc., we found angle B. But let's say, hey, we did the work, we used law of cosines, we found 10.5, but we don't know this angle B. We said we just, instead of finding B first, I want to find C first. What is that going to do to our numbers, and how is that going to affect what we're doing? So here we go. Let's say we found angle C instead of B. What could C equal? So we're not looking for this. We're going to find angle C. So hopefully that's clear. I'll state it again. We just, brand new problem. We did law of cosines. We found 10.5. Now we're going to find angle C. So let's see what happens here. I'm going to use law of sines. Sine of C over the side opposite is equal to the sine of 42.3 over its sine opposite. Cross multiply. Divide both sides by 10.5. Do the math. So I'm going to just plug that in, do the math. Get the decimal value. Find out what the inverse sine of that decimal value is. And again, I wind up with two angles. But which two angles? Which one's going to work here? So let's walk through it and try it again. Just off the basis we know of angles have to add up to 180, and sides of a triangle, the bigger side's opposite the biggest angle, etc. So I'm going to say this is 55.8. If I add the two angles together, I get 98.1. All right, fine. Subtract from 180. That means angle B should be 81.9. Is this biggest? That's the biggest angle. It's opposite the biggest side. We're good. Smallest side, opposite the smallest angle. This is good. Yeah, this could work. And if you look back at our other triangles, we're off by a little rounding based on a rounding error, but this would match the other triangle when we were finding angle B first. But it could be 124, so let's put 124 in for C. Add the 124 and the 42.3, subtract from 180, and that'll give us 13.5. And obviously, this can't be the biggest angle opposite the biggest side, so we know this isn't going to work. But one quick way too is you can look and say 142 degrees, this is opposite a side that's smaller than the biggest. So when you do it this way, when I look at this, I can say, you know, I don't even have to go through all this work. I can just nix this out and go with this angle and then find the third pretty straightforward, pretty easily. So what I'm trying to say through this, if you want to take a look at it again, is typically when you have a side angle side triangle, when you use law of cosines to find the opposite side, typically you'll want to find the smallest of the two angles. So I found 10.5. Between these other two angles that I don't know, which is the smallest? 15.4 or 12.9? I know, silly question. 12.9 is the smallest, so I'm going to want to find angle C first. When you do this, you will get two answers, like we did, but this other answer is going to be so big, it can't be a bigger angle than what we have here. You can automatically nix it, and you can just take your first answer. But if you go for the other side, the side that's bigger, and you go for that, you've got two answers, and it's going to be difficult to figure out which one actually works for the problem. So you may have to do a little bit more work. So if you get stuck on problems, you're not getting the answer, doing the homework, you may want to think of that a little bit. All right, so here we go. Side, 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 or the SSS worksheet. There's a worksheet. You should have it already. If you don't, ask the sub. She should have it for you. I would like you to go through the worksheet. So when you do that, it's going to be a lot of work, but it's great practice, and I want you to find some things out, just kind of like we just did on the last couple slides. After you use law of cosines, there's choices on what you can do, and based on those choices can give you more work or more answers trying to figure out. We kind of figured out from the last one that if I use for a triangle for side angle side, if I use the law of cosines to find the next angle, I'll use law of sines, but I want to find the smaller of the other two angles. That'll help eliminate some work. So what I want you to do is pause here and work on the worksheet, and when you're finished, come back. All right, welcome back. Hopefully all that work didn't wear you out. Again, there's a reason for doing it. Hopefully I kind of stated some of that in the worksheet. This slide I have here, when I was actually planning on being in class, I was going to have you talk to your table partner. Of course, hopefully you guys are sitting in different seats, and explain what you just learned about the nuances of solving an oblique triangle. We would have also talked about some other things, or all the stuff you did on the worksheet. So we want to talk about some of those nuances, but since you've already written that down, we don't have to do this. We can skip it and move on. All right, here's a problem you're going to get. Take a look at it. Find the length of a side of a pentagon inscribed in a circle with a radius of 6. So pause here. I want you to find, well, don't pause yet. I want you to find this length. What is this length of this pentagon if the radius of the circle is 6? So pause here, try it on your own. If you don't get it, I have the solution for you after this. If you do get it, it'll be great to check. But again, one of those good learning experiences. So pause it here and do the work. Try it. All right, so hopefully you paused and we're back. If you didn't pause, I'll probably be standing in class pointing to the sign behind my desk saying, hey, if you're putting work into it, it's going to build those brain connections. So here we go. It's a radius of 6, so I know I can put a radius on this side and a radius on this side. It's a radius of 6. The question is, what is that angle? One way we can look is just basic geometry, is I can slice up the radii to the vertices of the pentagon nice and evenly, and now I have 1, 2, 3, 4, 5 equal angles. Pretty straightforward. I just take 360, divide by 5, and I get 72. So now I know that that angle is 72 degrees. So let's take a look at the problem the way it stands now. We have two radii of 6, an angle of 72. How are we going to find the opposite side? Well, this is a side angle side. Side angle side tells us we're going to use law of cosines, and that's what I've done right here. Got the law of cosines set up nicely for you. You can follow the work, so the opposite side should be 7.1. So again, you'll have problems similar or of this concept type in the homework. You can refer to this if you're stuck on some of those homework problems. And actually, looks like I messed up on the video. I was going to do step by step, but I'm so far into this, I'm just going to let it go and you guys can figure it out. All right, a cool problem. I mean, maybe they're using this helicopter flying looking for debris or stuff from that Malaysian jet that went down, etc., but this could be anything. A helicopter leaves port searching for a down plane on a bearing of 28 degrees. Remember what a bearing is. If you're having difficulty, talk with somebody else in class. So this helicopter leaves on a bearing of 28 degrees and travels 4.3 miles. The helicopter then turns due east and travels 8.2 miles when he spots the survivors that he was looking for. How far are the survivors from the port, and at what bearing will a ship have to travel to pick up those survivors? This would be a good time to pause the video, make a good drawing, try it on your own, and then come back and see how you're doing. I guess I can say welcome back. I don't have step by step, but what I did is I drew it out. We're starting from the port, flying on a bearing. Remember, bearing is from the north. I just go clockwise 28 degrees. Helicopter flies 4.3 miles. Turns due east, just kind of keeping it simple for you guys. We'll see what the problems in the homework look like. Flies for 8.2 miles and then turns and returns. We don't know what that angle is. It turns and returns. It turns and returns back to port. But the idea now is the ship is going to go pick up these survivors. It needs to know, or they need to know, how far the ship had to travel and what bearing, and the answers are right here. Has to travel 10.9 miles out of a bearing of 41.6. So for this particular problem, I don't have a step-by-step for you to follow, but I think there's enough kids in the class doing it. Take a look. If you got the answer, you're golden. If you messed up, take a look at what other students are doing and learn from that. Hey, there you go. Time to do my math lab. Again, hopefully this works, at least maybe clarified some stuff. If you have time to do homework, start that. That'd be great. If you didn't finish this, hopefully you're at home finishing it now. And the homework, again, is online, or you can get the PDF version. Anything else I need to say before I finish up here? Nothing. Oh, yeah, one thing. That worksheet that you did, the SSS worksheet, that needs to be turned in on the next class day. I need that turned in so I can take a look and see the work that you did and see the comments and the cool little golden nuggets you guys came up with. So I'm done with this. Hopefully it works out for you, and I'll see you when I get back. Bye.